Asia accounts for almost half of all the world's energy demand. It's now also the highest emitting region. But that's half the story. Asia is now creating a renewable energy transition, a transition that could move the needle on climate change.
This is also a region that has a diverse availability of renewable resources. And what we've seen over the past decade is that these are also countries that have shown immense amount of commitment in getting their policies and regulations together to foster a speedier deployment of renewable energy.
This is the decade of action. The next decade will also be the decade of action. So maybe this is the half century of action as we radically decarbonize our economy. We need to pretty much halve greenhouse gas emissions this decade, and that's about every business, every government, every institution, and individuals playing their part in this process.
What does the future hold for Asia as it races to decarbonize? Asia is the fastest growing region in the world, but that growth has come with a price. Carbon emissions are warming the planet. Now, Asia and the world are in a race to decarbonize, to accelerate a renewable energy transition, to slash emissions from transportation, and to have capital catalyze innovations and action across the globe. The race to get to net zero by 2050 has begun.
Heavy rains have left large parts of China's central Henan province underwater. Millions of people have been affected.
Firefighters contained 2 bushfires in Western Australia. Some parts, though, are still in danger.
And no respite for India as it braces for its second powerful storm in less than 2 weeks. And nearly 2 million people are being moved to shelters before it hits.
Today, 75% of Asia-Pacific's GDP is exposed to climate disruptions, with 50% of the world's labor force impacted. The cost of doing nothing could be economically devastating. $96 trillion in losses could be incurred by 2070 if nothing is done. At the same time, Asia is growing fast, and to sustain that growth, it needs 50% more energy. The goal is for all that energy to be produced by renewables.
We've produced a first trillion watts of solar power. That's about 5 billion solar panels, so almost a solar panel for every man, woman and child around in the world. And that took from the 1950s to do that trillion watts. The next trillion watts is going to take just 4 years. The race is on to tackle climate change, and you could say it's the race of our lives, and we've got a chance to win it, but we could equally lose it.
Asia is making big moves to grow investments on renewable energy. Within the continent, in Southeast Asia, governments have made plans to boost deployment. Almost a decade ago, 1/10 of the region's energy mix consisted of renewables. It has set new targets to have renewables make up almost 1/4 by 2025.
Whichever direction the energy system takes, a large part of that is going to be determined in Asia. And I think one of the encouraging signs is you're getting the emergence of all sorts of new clean energy supply chains across Asia. Asia is taking the lead on many of the technologies that we know that we will need in order to have a low emissions or net zero emissions energy system.
Solar continues to grow the fastest among those new clean energy supply chains, especially in the Philippines, which is a very good place to harvest the sun's energy. There, ASEN is at the forefront of a rapidly growing renewables sector. The company aims to produce 5,000 megawatts of renewable energy by 2025, almost double its current capacity in 2022.
We have a very strong pipeline of projects. A lot of these are shovel-ready, both in the Philippines and across the region. We started to build the renewable pipeline 5 or 6 years ago, so we've got the head start and selected the best possible sites that are appropriate for renewables. We are witnessing the dawning of the renewables era.
ASEN's Alamino solar and storage hybrid facility is a model for how its solar farms in the pipeline could be designed. There are nearly 300,000 panels in total, surrounded by a woodland reserve, which acts as a carbon sink and is home to vast biodiversity. A plastic recycling facility will be built nearby, demonstrating the circular economy in action. Plastic waste will be upcycled here to make eco-bricks, used as materials in construction. During their pilot project, more than 32 tons of plastic waste were valorized. And the Alaminos solar plant provides enough power for 80,000 homes.
We're doing this circularity concept in other projects around the Philippines and hopefully soon across the region as well. We also wish to continue the circularity project through waste management recycling program involving the community. When we talk about sustainability, we do not only cover the environment, but also the social aspects of it.
Now, this solar plant is connected to a battery energy storage system, making for the first hybrid solar and energy storage project in the Philippines.
And this allows the facility to avoid more than 100,000 tons of carbon emissions per year. We believe that battery storage is a critical element in order to unlock the full potential of renewables, because battery storage will be the effective solution to address the intermittency of the renewables, to make renewables more reliable.
While large solar plants provide reliable, clean energy to national grids, other new solutions of a lesser scale are playing a big role in empowering whole communities and accelerating a renewable energy transition in their own way. There are about 800 million people living in remote communities around the world, unserved by the grid, with no access to electricity. The World Bank estimates that 200,000 microgrids are needed to bring electricity to those who don't have it.
Microgrids, in our opinion, is the fastest way to electrify billion people, and it is also the most capital efficient way to do so. Microgrids contain solar PV, which is a renewable source of energy, biomass gasification system in husk case and storage. So it is a net zero system. And when we deploy it in areas in emerging economy that do not have any power, they typically have hundreds of diesel generators running. All those diesel generators are eliminated. So it is the fastest way to electrify. It is short way to eliminate diesel to zero. And it is the best way to provide electricity at an affordable price point to end customers.
In general, a renewable energy microgrid works like this. Solar PVs harvest light. These solar farms then transmit electrons through cables into a battery, which stores it. A regulator controls the optimal amount of energy the battery receives and the optimal amount transmitted to homes and the village. The beauty about the system is that even though the energy coming from the sun might be intermittent, there's still a constant supply of energy available for the village.
Imagine a community that does not have any power. They get power, their lifestyle improves dramatically because now they have access to power. Their children can study. On the commercial side, they were very manual oriented. Their productivity increases because they now have productive appliances running on electricity. So there's a huge socioeconomic development that occurs with the microgrid that is brought in.
Indeed, a renewable energy transition is well underway, with strong adoption rates just in this decade alone. Solar's growth has been promising, hitting rates of 33% annually, while wind turbine use grows by 25% each year. Hydropower remains the largest renewable energy source, but growth is at 2.1% annually. While strong rates of growth raise optimism for a cleaner, more sustainable future, the reality is that coal, oil, and gas continue to make up 80% of global energy supply. As the world races to increase adoption of renewables, interest builds for other less ubiquitous sources of renewable energy, like geothermal energy. It's always on, so there are no intermittency problems like wind and solar. But growth in geothermal energy outputs are disappointingly slow. It supplies just 8.3% of the world's electricity.
Now, if you look globally, this is unfortunately not a resource that has really been exploited too much. And we see just about 15,000 megawatts of geothermal power is currently available in the system globally, whereas the potential is 200 gigawatts, so much, much more. This is a resource that could actually power the grids at the utility scale. The challenge, of course, is that it is a very expensive proposition. A large amount of cost is actually the cost of proving the feasibility of the project. And that, in a way, is like a sunk cost in case you don't really get the kind of resource that would make it cost-effective to harness the energy coming from geothermal.
The most common way to harvest geothermal energy is by drilling a well deep underground, then piping the heat up to power a turbine, which generates electricity for a grid. But exploration to find hot fluids underground is an expensive and time-consuming process with no guaranteed results. New developments could make geothermal plants more accessible and scalable. Ever Technologies uses a series of multilateral wellbores forming a closed loop. Fluid is circulated through this so-called Ever loop, which is then naturally heated by the Earth through conduction. When the hot working fluid reaches the surface, the heat picked up underground can be used to generate electricity. The system creates a reliable and consistent source of carbon-free energy, and it can be deployed anywhere, everywhere, even near cities. And there is another sort of renewable energy transition underway. This is Singapore's new Twas Megaport. Upon completion in the 2040s, Twas Port will be the largest fully automated terminal in the world. Inside the maintenance base, this 6-story administration building is a net zero energy building. It generates all the energy it uses.
There are 3 main innovative technologies used in a Twas Port admin building. They are passive displacement cooling, building applied photovoltaic system, also known as BAPV, and model predictive control.
The building's external facade is fitted with solar panels. These are supplemented with rooftop solar panels to maximize the amount of renewable energy generation on site. Inside the building, spaces are cooled with minimal energy. Smart technologies regulate the amount of energy used for cooling, while spaces are designed to promote natural circulation of the air indoors.
With various innovative technologies incorporated into the building, is expected to use 58% less energy annually as compared to other similar size buildings. These innovative features sets the stage for all future buildings in Singapore.
Net zero energy buildings can certainly help countries decarbonize. But what if a country doesn't have all the right conditions to harvest enough renewable energy for all its needs? The answer could involve interconnected grids, an arrangement where countries with ideal conditions for producing renewable energy sell their renewable energy to others.
I think it is an economic opportunity. It opens up the possibility for the countries that are more proactive in getting their policies in place and deploying renewables to be able to export the excess to the neighboring countries that might need it at the load centers. You're looking at number of countries which will all have to come on the table and look at the economics for each one of them to be a win-win situation for them.
In Southeast Asia, an interconnected grid involving a number of countries is underway. The Lao PDR, Thailand, Malaysia, Singapore Power Integration Project was announced in 2021, sharing access to renewable energy to all who participate in the trading arrangement. and enhancing energy security for every one of them. The arrangement gives fresh traction to long-standing plans for an ASEAN power grid, which was first conceived more than 2 decades ago. Energy fuels everything in the world. But there needs to be a revolution in the way our energy is produced. New technologies, applications, and collaborative efforts promise greater momentum for a renewable energy transition. A transition that would really move the needle on climate change.
This program is produced in partnership with Temasek's Ecosperity platform.